Hey, we're on 4.4 today, which is finding an equation from its graph. So normally what we would do in the past 3 lectures is we would be given an equation and we'd have to graph it from there. Well, we're going to do the opposite today. We're going to be given the graph and we got to figure out what the equation is. So let's think back. Let's start with a little throwback. I don't know if it's Thursday or not when I'm recording this. It's Friday when the day I'm recording it. However, when you're watching it, it might be Thursday, so it's kind of a throwback Thursday, if you will. So think back to algebra. When we wanted to find an equation of a line, we used the form y equals mx plus b, where m was your slope and b was your y-intercept. Well, let's look at this graph here. My origin's here, so my y-intercept is at this point here, which is 0, 2. So my b value would be 2. Secondly, we need to figure out what the slope is. Well, we'd make our triangle. It went down 1. It ran 2. So my slope then is negative 1/2. Putting that into my equation, we have negative 1/2 x plus 2 was my equation of my line. So we're going to use the same types of ideas. So we got to figure out using my generic trigonometric function, as we've seen a lot of lately. We need to figure out what a, b, c, and d are. Now to start out, what we're going to do is we're always going to draw a horizontal line, dashed line, going through that cuts through the center of my trig function, my trig graph. Why? Because, well, that helps me figure out what, first off, my amplitude is. Well, my amplitude is from the dashed line to the peak, which is 3. So my a value is 3. B value is talking about my period. Related to my period. It wasn't my period in fact, but it helped me find my period. We got to remember that my period is equal to 2 pi over b. So we're going to use that. Well, we pick a starting point where we know that we can follow it until it repeats. Well, I pick there for now. I like the origin. So we follow it up, down, up. Oh, look at that right there. So this is my period. Well, that's going to be pi over 2, pi over 3 pi over 2, and then 2 pi. So my period is my normal 2 pi. And you might be able to make the jump right away saying, oh, if my period is 2 pi, my b value is 1. But if you can't see that, we can kind of write it out here. My period was 2 pi, and that is to be equal to 2 pi over b. Cross multiply, I get 2 pi b is equal to 2 pi. They cancel, my b value is 1. So b value is 1. Now I'm going to skip c until the end. I always like to do c last. But d value, though, is my... Did I vertically shift this at all? And that's just the simplest finding out. Oh, is my dashed line that I drew, is that on the x-axis or not? If it's on the x-axis, I'm not shifting it up or down. If it isn't, then we have to figure that out. We'll see some examples later. So I get that my d value is 0. Now, why did I leave c for last? Now, this might surprise some of you, but there are an infinite number of equations that I could write for this graph. There's no one right answer. Well, why is that? Well, because I can start from here, right, and follow this around, and you might be able to see right away, oh, that looks like a sine curve. Well, cool. In that case, what do we get? If I do choose to start right here, and I start here and follow it up, and there, did I shift it left or right at all? Did I move for my parent sine function? No. So you could say that c is 0. And what would your equation be then? Well, it would be a sine, because I'm starting at the y value 0 and starting there. So I would have y is equal to, my a value is 3, sine, my b value is 1, so I just have x. So 3 sine x. This is an equation that for this graph. However, what if I was like, what if I wanted to start here at the peak? So we follow the peak till we hit a repeat. Okay. So that's one period of what? Well, that's one period of cosine. So we could potentially write this as a cosine function as well. Okay. So what happens if I wanted to write this as a cosine function? My amplitude doesn't change. My b value doesn't change. It's still a period of 2 pi. My d value still doesn't change. I'm not shifting it up or down. But where does my original cosine function go? Well, that follows this. Oh, let's see if I can. There we go. This is my original cosine function without a phase shift. And how far did I phase shift it to the right? I phase shifted it pi over 2. So you could potentially also say that c is pi over 2 if you're writing a cosine function. So in that case, what would it be? It'd be y is equal to, my amplitude's still 3, cosine, my b value is 1, and my c value is x, so x minus pi over 2. And how about that? Here are two perfectly legitimate equations for this trigonometric graph. And again, you could pick this as a starting point for all I care. In that case, you would have a negative cosine graph. So let's do another one here. How do I start? I always start by drawing a dashed line, cutting my graph in half. Why? Because, well, that helps me figure out some values. My a value, for instance, is the distance from my dashed line to the peak. Well, that's just a distance of 1. My b value, right? We got to pick a place for this thing to start. Well, I'm going to pick there to start. And I'm going to follow this along until it starts to repeat. How far of a distance is that? Starting at 0, going to pi. So my period is pi. Well, I know that period is 2 pi over b. So I'm going to set up pi is equal to 2 pi over b. Cross multiply, I get that pi b is equal to 2 pi. Pi's cancel. I get a b value of 2. And if you can see that right away, great. That's awesome. But I just want to show it for everybody, just so we really can hammer out, oh, that's how I find my b value. Right, I'm going to leave c, because it depends on where we choose to start. And then my d value. Did I move this thing up or down? Well, that's as simple as finding out how far did I move my dashed line up or down. That's just positive 1. Now, I'd personally really like to pick cosine. Cosines are easier in my mind. However, we're going to do this question both ways. And then from now on, I'm just going to do them in terms of the easiest one, just one of them, instead of both of them to save time. So if I chose to start here, I'm starting at my peak, so I know that's a cosine. So if I start as a cosine, did I shift this thing left or right? No, it's still starting at 0. So I'm shifting it nothing. There's no phase shift here. So how would I write this out in terms of cosine? Y is equal to 1, I'm going to leave that off, cosine of 2, my c value is 0, so it's just 2x, and a vertical shift of 1. So one perfectly legitimate equation is y equals cosine 2x plus 1. However, if I wanted to write it as a sine curve, well, sine curves start at the dashed line, right? At wherever the quote-unquote 0 mark is. So potentially right there. If we were to start right there, we would follow this along, and we'll use a different color for emphasis here. Start right here, and I'd follow it along until it starts to repeat right here. My period didn't change, b value is the same, amplitude the same. My d value is, again, still 1. I'm shifting it up 1. However, my c value is going to change. I am phase shifting it if I'm starting here, and I'm shifting it pi over 4 to the right. So if I'm writing it in terms of sine, it shifted pi over 4 to the right. But what's different about this sine curve than normal sine curve? It's the fact that once I start by going down. Normal sine curve starts by going up and down, up and then down, and blah-de-blah-de-blah, like that. So because of that, I have to multiply this whole thing by a negative 1, by a negative sign, because it's flipping it over the dashed line, the starting point. So if I were to write this in terms of sine, it'd be y equals negative sine, because my amplitude's 1, my b value's 2, and I am phase shifting it this time by pi over 4, and then it's a vertical shift of 1. So these are both perfectly legitimate equations that you could write on a test. Alright, ooh, this one looks like a whole bucket full of fun. So right away you're thinking, oh, well, that's probably just tangent. And that's great if you can immediately see that. Remember, the tangent is that disco function. Right, I have my asymptotes at negative pi, pi, 3 pi. But remember, normal tangent starts down here and goes up. So you could either think of this in terms of, oh, that's a cotangent, because I know cotangent starts top left, goes bottom right. Or you can think of it in terms of a negative tangent. Now, since we usually try to just keep things in terms of sine, cosine, tangent, I'm going to write this one as tangent. All right, so my amplitude. My amplitude, to figure that out, I have to draw my values, my intervals, halfway in between 0 and my asymptote, so pi over 2. And you have to think, oh, does my y value equal 1 at those intervals? And you say, yes, it does. So because of that, my amplitude doesn't change. It's still just 1. To reiterate that, you draw an interval halfway in between 0 and your asymptote, and you look, does the y value at that point equal 1? If it does, your amplitude's 1. If not, then you have to figure out what your amplitude is from there. Well, my b value, remember, the normal period for tangent is pi. So on either side of the graph, on either side of the x-axis, y-axis, sorry, it's half of that, pi over 2 on either side. However, if we draw out my period for this curve, it's from negative pi to pi. So the period of this is 2 pi. So let's figure out what b is from there. Pi over b is equal to my period for this curve, 2 pi. Cross multiply, I get that 2 pi b is equal to pi. Pi's cancel, and my b then is 1/2. We're going to leave my c value for last because that's how I always do it. And then vertical shift, did I shift it up or down? No. It starts in the origin, so we didn't shift it. C value, did I shift it left or right? No, because it still starts at the origin. It doesn't start at a random point, so my c value is 0. So we can write this out. Remember, this tangent graph is flipped. It starts top left and goes bottom right. So it's a negative tangent. What's my b value? 1/2. There's no c or d. So it's just negative tangent 1/2 x. Remember, you could have written this in terms of cotangent. In that case, it'd be y equals cotangent 1/2 x. That's also perfectly legitimate. All right, what about this curve? Remember, we always start by drawing my dashed line that cuts it in half. My dashed line is at negative 2. Why do we do that? It helps us find amplitude. What's the distance between my dashed line and my peak or valley? Well, that's just negative 2 to negative 4, so it's a value of 2. What's my b value here? Well, to do that, we pick a starting point. Now, I like to start at the peak and go from peak to peak because it's easier to see for me. So you go, it starts at negative pi over 4, because that's my interval. Negative pi over 4 all the way, 7 pi over 4. Negative pi over 4 to 7 pi over 4, that's a distance of 2 pi. So it's my normal period, so my b value has to be 1. I'm going to leave c for last again, I always do that. But what about my d value? Well, that's the distance that my dashed line has dropped or risen. It's dropped 2, so it's a d value of negative 2. Now, if I'm starting at peak to peak, I'm going to make a cosine graph here. In that case, how far left or right did I shift my starting point? Well, I shifted it pi over 4 to the right. Oh, sorry, to the left. So it's a negative pi over 4. Let's put everything together. I'm making it a cosine. And just to clarify, we also have to check if it's been flipped or not, if it's a negative sign out front. Well, cosine starts at a peak and ends at a peak, so the way I chose my starting and ending points, I'm not flipping it. If I had chosen the point down here and gone valley to valley, then yes, I would have that negative sign out front, but it'd also be a different phase shift. But by the way we chose it, this is going to be a positive cosine. So y is equal to my a value is 2 times the cosine. B value is 1, so it's just going to be a 1 out front. X, Now I'm shifting left pi over 4, so it's going to be x plus pi over 4. Remember that backwards thinking we talked about last lecture. And then a negative 2 for the vertical shift. One more time, we draw our dashed line through the middle. Now if you can't see that just off the bat, and you can't really figure out, well, where does my vertical shift, where does my dotted line go? You take a peak at 5, take a valley at negative 1, and you're going to average it. 5 plus a negative 1 divided by 2, well, that's 4 over 2, so my dashed line goes at 2. So you just have to average them. Now let's find amplitude, my B value, my C value, and my D value. Well, what's the distance from the peak to the dashed line? Well, that's just 3. So my amplitude's 3. So we're going to pick a starting point and ending point. Now, it's easy for me to see this valley as a starting point. Why? Because, well, I don't have a second peak to go off of. But if you wanted to start right here instead and go make a sine curve out of it, that's also great. I'm going to keep it as cosine because I find it easier to pick starting and ending points. So I'm going to go valley to valley here. Valley, valley. So we're going from 0 to 6. Well, that's kind of uncomfortable because there's no pi's here. But that's okay. That's okay. Remember, my normal cosine period is 2 pi. My period here is 0 to 6. So my period is 6. So let's just set up that equation again. My period of 6 is equal to 2 pi over b. Cross multiply, I get 6b is 2 pi. So my b value has to be pi over 3. Nothing too fancy, just pi over 3. What's my d value? My d value is how far my dotted line has been shifted from the x-axis. It's gone up 2. And then lastly, c value. My c value is my phase shift. Did I move, if I pick this as my starting point, did I move it left or right from the y-axis? No, so it's 0. Now remember, I'm starting at a valley. Cosine normally starts at a peak, so I have to tack on a negative sign out front. So it's going to be a negative cosine. Ooh, I forgot my amplitude. I do have an amplitude of 3, so it's a negative 3 cosine. Excuse me for that. My b value is pi over 3. I have no c value, so it's just pi over 3x, and then a vertical shift of plus 2. And then one final one. Immediately see this parabolic motion, and you should hopefully be able to look at this and say, hey, parabolic motion, it's going to be either a secant or cosecant. So we need to determine what the reciprocal function is first. So if I create on this my peaks and valleys here, remember my reciprocal identities share the peaks and valleys. So I'm going to connect them with a trig function that I don't know what it is quite yet. And then go from there. So we're going to again draw my dashed line through the middle of this one that I just created. Now it's not going to be exact because I hand drew it and I'm pretty bad at hand drawing, but hopefully we can kind of see, get an idea. I'm going to redraw this just a hair, just so we get a better idea here. That should go through. No, I want purple. Should go through 2 pi. Like that, and then go up. Okay, with this in mind now, can I figure out what the equation of this purple line is, purple curve is? Yeah, pretty easily. Just do what we've been doing all lecture. My a value, my b value, my c value, and my d value. A value is the distance from a peak to the dashed line. So from 1 to 3, that's 2. My b value is the period. So let's pick a starting point and an ending point. Well, I'm going to pick this starting point and this ending point. So this is negative pi over 2 because that's one interval. So I'm going from pi over 2 to 3 pi over 2. How far of a distance is that? Well, that's just 2 pi. So hopefully you can see, oh, that means my b value needs to be 1. It's my normal period. Negative 2 pi to 3 pi over 2. Boom. 2 pi. I'm going to leave c value for last. What about my d value here? My d value is the distance I moved up or down my horizontal dashed line. Well, I just moved that up 1, so I have a vertical shift of 1. My c value is, well, I picked this as my starting point, correct? How far left or right did I shift that from the y-axis? Shifted it left, pi over 2, so it's a negative pi over 2. So let's figure out the equation of my purple curve. And then from that, we'll determine what my final answer is going to be. Putting this all together, remember I'm starting at a peak, so it's going to be a cosine. So it's going to be y equals, my amplitude is 2, I'm not tacking on a negative sign since I'm starting at a peak, cosine, my b value is 1, but I am shifting it to the left pi over 2, so it's x plus pi over 2, and then a vertical shift of plus 1. Now, all I have to do in order to turn this into my final answer is to just replace cosine with its reciprocal identity, which is secant. So my final answer is going to be y equals 2 secant x plus pi over 2 plus 1. Now, you may also have decided, I'm going to start at this starting point. Make a curve, go from start to end. You would eventually make a sine equation over there instead of cosine. And in that case, with a different period shift, a phase shift, sorry. And in doing that, you would have made a sine curve. And then your final answer would have been a cosecant instead of a secant. However, the way I did it, I like to do cosine. So if you like to do sine, that's perfectly fine. On a test, I can't count that wrong, because it's the right equation. It's an equation for that curve. So it's your choice. Just so you are aware, there are multiple ways to do it. Actually, an infinite number. So check out write a summary and answer any questions, ask any questions, and I'll try to answer them in class, and then take a look at your assignment.